Alright guys, today we're going to go through trigonometry, set 23. Okay, so with trigonometry, we always look at right angle triangles and their angles. Okay, so with this triangle over here, we know that it is a right angle triangle because of this angle over here, which is a 90-degree angle. And once we figure out what the right angle is, we look at the other sides. So for example, the side directly opposite to the right angle triangle will be the hypotenuse, which is the longest side of the right angle triangle. Okay, and then we also have a given angle, which we call the reference angle. Okay, so over here it says reference angle, which is theta, and this length, the side length directly opposite to the reference angle will be called the opposite. Okay, that's the side directly opposite to the reference angle, and the side that's left is adjacent. So with the adjacent side, it has both the reference angle and the right angle triangle. Okay, so over here we've got the right angle over here and the reference angle over here. Okay, and that's the adjacent side. You'll need to remember how to identify the sides of the right angle triangle, because when we're doing questions, you'll be given unknown lengths and unknown angles, and you'll be asked to figure out what the sides are and figure out what the unknown angle is. Okay, so that's why you need to know what these sides are. Okay, let's have a look over here. I'll give you guys an example. Okay, we had an angle over here and this was the right angle. This will be what? This will be the hypotenuse. Okay, and what would this side be? Remember, we've got the reference angle and the right angle on one side, which would make this the adjacent. What about this side? It's directly opposite to the reference angle, so that side will be the opposite. And that's it. That's all you need to know in identifying the sides of a right angle triangle. Okay, let's have a look. And remember, the sides change according to the reference angle. So for example, if the reference angle was alpha, right, let's put that in a different color so that you guys can identify the difference. Let's do red. If the reference angle was alpha, the hypotenuse will still stay the same because it's always the longest side of the right angle triangle. Yes, this will still be the hypotenuse, but this will be the adjacent, and this will be the opposite. Okay, that's how we change the side lengths according to the reference angle. Okay, let's move on to the next part of the course. Let's have a look. The calculator. Okay, so when you're doing trigonometry questions, you'll always need a calculator. Make sure to use a scientific calculator because the normal accounting calculators wouldn't have trigonometric values. Okay, and remember to put your scientific calculator in degrees mode, because by default it will probably be in radians. Just change the settings to degrees mode so that you can do these questions for this set. Okay, and when you're we'll have a look at this example. We're asked to find tan 24 to 2 decimal places, so you'll just put tan square brackets 24 degrees and it'll spit out the answer. Okay, to 2 decimal places it'll be 0.45. alrighty, and what you need to do is you don't need to put the degree sign if your setting is in degrees, but if it's not, you have to put the degree sign. Okay, and if we had, say for example, sine theta was 0.31 and we need to find what theta is, what we need to do is we need to make theta the subject, right? So when we're making theta the subject, the sign goes over to the other side and becomes an inverse sign. Okay, this is the symbol for inverse sign, and we put the decimal value in brackets. Put sine inverse 0.3 in the calculator, and then you'll find the value of the angle, which will be in degrees. Okay, and these are some other calculator functions that you can do. I suggest you guys just try these on your calculator and have a feel of how to get these numbers when you're doing questions. Okay, let's move on to the next one, the sine ratio. The sine ratio is the ratio that you get by doing opposite over hypotenuse. I want you guys to remember this acronym. Okay, so oops. Okay, so means sine is equal to opposite over hypotenuse. Cut means cos is equal to adjacent over hypotenuse. And TOA means tan is equal to opposite over adjacent. Okay, this is what you guys need to remember. Adjacent over hypotenuse, sorry. Alright, remember this acronym, which will help you guys a lot when you're doing your questions, okay? So, as we said over here, sine is opposite over hypotenuse, and whenever we've been given the reference angle, what we need to do is, if we're supposed to find theta, what we need to do is we need to use sine theta is equal to opposite over hypotenuse if we've been given the values for the hypotenuse and the opposite side lengths. Okay, let's have a look at the example over here. In the example, it says it asks us to find x, which is what? If this is the reference angle, x will be the opposite side. And we've been given the hypotenuse, which is 12. We know that this is the hypotenuse because it's directly opposite the right angle and it's the longest side of the triangle. Okay, what we need to do is we need to find x. To find x, we need to use this formula here. Sine theta, so what's theta? It's 63 degrees, is equal to opposite over hypotenuse. Opposite is x, hypotenuse is 12. To make x the subject, we just do x is equal to sine 63 degrees is equal to, times by 12. Put this in the calculator, which should give you 10.69. Okay, and that's our length in centimeters. Done. Okay, same thing, you just over here, what have we been given? We've been given the opposites. We've been given opposite as x, and we've got hypotenuse as 300 meters and the reference angle to be 37 degrees. Okay, we can do sine 37 is equal to opposite over hypotenuse. Opposite will be x, hypotenuse will be 300. What you need to do is make x the subject, so you do 300 times sine 37, put it in the calculator, and you should get the answer below. Okay, let's move on to cosine. Remember TOA, this is CAH, cos is equal to adjacent over hypotenuse, which has been given over here. Okay, so we'll do the same thing. So let's have a look at this example over here. We are given the reference angle to be theta. Okay, and what's the sine? This is the hypotenuse, it's directly opposite to the right angle, and we've been given the adjacent as well. Okay, cos theta is equal to adjacent over hypotenuse. What's adjacent here? It's 5 because it's the side with both the reference angle and the right angle. And the hypotenuse is 8. Now, how do we find the theta value? Because before we found the side lengths, but now we need to find the angle. So to find the angle, what do? We make theta the subject. Theta is equal to, we're taking cos over to the other side, which makes it cos inverse 5 over 8. Put this in the calculator, it should give you something like 51.3132. Okay, and when you get angles, you need to can round it up or down to the nearest degree. Okay, so when we get 51.31, we'll probably round it down to 51 degrees. Unless they ask you otherwise, okay? It says to the nearest minute, so we just round it to the nearest angle, okay? Let's have a look. Tangent ratio. So the tangent ratio, it's TOA, meaning tan is equal to opposite over hypotenuse. Let's have a look at this example over here. We've been given this side, which is, what is this side? It's got the right angle and the reference angle, which means this is the adjacent. And we've been given opposite as x, directly opposite to the reference angle. And we've been given the reference angle to be 42. So we just need to put this into this formula over here. So we have tan 42 degrees is equal to opposite over adjacent x over 8.7. Make x the subject. X is equal to 8.7 tan 42 degrees. Put this in the calculator and see what you get. Okay, you should get something like 7.8 centimeters. Oh, this is a good one. We've got a problem question. A ladder leans against a wall 5 meters high. Okay, the wall is 5 meters high. So this is the wall. And if the base of the ladder is 4 meters from the wall, so the base of the ladder is over here. And the ladder makes an angle. Oh, we don't know what the angle is. We need to find out what the angle is. Okay, we'll put the angle over here, degrees theta, and we know that it makes a right angle with the wall and the floor, and we know that the distance between the ladder to the wall is 4 meters, and the height of the wall is 5 meters. What do we need to find? We need to find the angle that the ladder makes with the wall. So what have we been given? We've been given the opposite side, we've been given the adjacent side, right? So we have tan theta, is equal to opposite over adjacent. Opposite is 5, adjacent is 4, and we need to make theta the subject. To make theta the subject, we make theta is equal to, take tan over to the other side, tan inverse 5 on 4. Put this in the calculator, see what you get. You should get 51 degrees because we are rounding up or down to the nearest degree. Okay, this is the summary. You can have a look. Oh, there we go, SOHCAHTOA. There's another way you can remember it. They've given you a mnemonic. Some old houses can always hide their old age, but SOHCAHTOA is easy to remember. And you can have a look at these examples as well. Okay, let's do this question. What do we have here? We've got the angle, we've got the hypotenuse is directly opposite to the right angle, and we're supposed to find x, which is the opposite. To find x, we've got a opposite and a hypotenuse. Which two ratios does opposite and which ratio does opposite and hypotenuse have? That would be sine, right? So we use sine 51 because that's the angle is equal to opposite over hypotenuse. Opposite is x, hypotenuse is 7. To find x, we do x is equal to 7 sine 51. Okay, and that's it. Put this in the calculator, you should get the answer. Let's try this one. We've been given the adjacent because we know there's the reference angle and the right angle on the same side, and we've been also given the opposite, which is directly opposite to the reference angle. This is opposite. Okay, which ratio has opposite and adjacent? That would be tan, right? So we're using tan. Tan theta is equal to opposite over adjacent, 3 on 5, because remember TOA has to be opposite over adjacent, and we're looking for theta, so we do theta is equal to tan inverse 3 on 5, and then put this in the calculator, see what you get. Okay, remember to round it to the nearest decimal degree. Okay, let's have a look at angles of elevation and depression. With angles of elevation, you're looking up from a horizontal plane. Okay, so for example, if you were on the ground and you were looking up at a plane, that would make, let's make, this is you, and there's a plane over here, right? this would be the horizontal, and when you're looking up to look at it, this would make the angle of elevation. Alright, let's have a look at something on the floor. If you're looking down at something, say there was a little rabbit on the floor, okay, you're looking down at it. This will still be the horizontal. You're looking down this way, and this would make an angle of depression. Okay, this is angle of depression. It's the angle of elevation. When you're looking up, it's angle of elevation. When you're looking down, it's angle of depression. Okay, let's have a look at this example over here. A ship is sighted from a plane at an angle of depression of 34 degrees. Okay, so let's say the ship is here, the plane is here. The angle of depression is 34 degrees. Okay, oops, that's not very straight. Let me just redraw it. Yeah, 34 degrees. We also know that the distance from the plane to the ship is 5,000 meters. That's the shortest distance, so that will be this one, 5,000 meters. They're asking us to find the height of the plane. Okay, to find the height of the plane, what we need to do is find out this value. Get the side length of this side. What do we have? They've given us, that's 34 degrees, the hypotenuse, and they're asking us to find the opposite, which is this side. To find that, what can we do? We can use sine 34 is equal to opposite over hypotenuse. Opposite is x, hypotenuse is 500. Right? Yep. And now, just look for x. To make x the subject, we times sine 34 by 500, so we have x is equal to 500 times sine 34 degrees. Put this in the calculator and you should get the answer, which should be 2,796 meters to the nearest meter. Okay, you can do it in a different way. That's how they've done it. You can use cos as well. Cos 56 and sine 34 are the same angle. Because why? They're complementary angles. To find complementary angles, we just take away 90 from the given angle. Okay, so sine and cos are complementary angles. So whatever sine's value is, it will be the same as cos 90 minus theta. Or cos theta is equal to sine 90 minus theta. That's why you'd still get the same answer if you do it this way. Let's have a look at this. Oh, that's what they've given right here. Okay. So have a go at doing it both ways and see if you get the same answer. If you did, you've done it correctly. Okay. Let's have a look at bearings. Bearings give you a position from true north. Okay. So for example, if you were here, let's have a look at the examples here. If you were at A to B, right? If you went from A to B, what's your direction relative to true north? True north would be just north, right? North at 0, 0, 0 degrees true. Okay, that's where have a look at a clock, right? If you have a look at a clock and identify where 12 o'clock is, that would be true north. Okay, let's think about it that way. And say you moved from the middle of the clock to say between 1 and 2, and you made a 60-degree angle. Your bearing would be 0, 6, 0 degrees true. Okay, remember to always give your bearing in 3 figures, because if you're doing true bearings, you need to always give it in 3 figures. Okay, And if you were starting at the middle of the clock and went this way and it was 5 degrees, you would need to give your bearing as 005 degrees true. Okay, or alternatively you can do north 5 degrees east. Okay, meaning you went 5 degrees from north towards the east side. Okay, let's have a look at this one. Number 2, you're going from north to not north, you're going from the middle Q to P, right? Say you're here and you're going this way. From north, you need to calculate what this angle is. Over here they've given us that the angle is 150, so we know that it's 150 degrees T, right? But what if you needed to calculate it with reference to south and east? So what you do is you figure out how much from south towards east is this place, right? So we know that this is 150 and south will be what? 180 because it's a straight angle. And we just figure out what the difference is. 180 minus 150 is 30 degrees. So we just do south, 30 degrees east. So meaning you're starting at south and you're moving towards the east, moving towards east at a 30 degree value, okay? Moving 30 degrees towards east would be a better way to say it. Let's have a look at the third example. So we're starting at north. So let's start at the middle and going over here. So let's start at north and figure out how much this angle is. They said that it's 300, so we know that the bearing will be 300 degrees true. If it's 300, we need to also figure out from north to west as well. If this is 300, what do you think the remaining angle is? This one will be 60 degrees because north to back to north will be 360 degrees. So what's remaining will be 360 minus 300, which would give us 60 degrees. Okay. Now that we know that it's 60 degrees, we just need to write it as north 60 degrees west, because to get from north to this place, it's just starting at north and moving 60 degrees westwards. Okay. And that's how you give your other bearing. You can give it in either way, but just make sure to do 3 figures for true bearings and write your answer relative to which direction for this one, okay? If you find yourself doing a 3-figure number, a number that's more than 90 degrees over here between 2 directions, you're wrong, so always check what you did wrong, okay? Let's have a look at this example here. A ship sails 170 kilometers on a bearing of 210 from port P. How far directly south of the port is the ship? Okay, so they've asked us to draw a diagram. We've done that here. The ship sailed 170 kilometers at a 210 degree bearing. Okay, so say this was the port and this is the bearing, that's 210. We know that this whole thing from here to here is 180. So this will be what? 180 minus 210, which is 30 degrees. Now that we know that this is 30 degrees, all we need to do is find out this side length, okay, which will be x. Okay, what do we have? They've given us a hypotenuse, which is this value over here, which is 170, and we're looking for adjacent because we've got the reference angle and the right angle on one side, x. And they've also given us the reference angle, which is 30 degrees. Let's put that into use. We've got 30 cos 30 is equal to adjacent over hypotenuse. Remember TOA, so CA is CAH. Adjacent over hypotenuse. I'll just write that for you. Adjacent is x, hypotenuse is 170. To find x, what we do is we do 170 times by cos 30. Put that in the calculator, you should get this value. And always remember, put the units when you leave your answer. And that's it. We will do the questions in a different video. Go through set 24 questions for trigonometry. Okay, let's go through question number 1. A ladder 3.2 meters long is leaned against a wall, making an angle of 38 degrees with the wall. So you can see over here, it's making an angle of 38 degrees. Find how far the base of the ladder is from the wall. So base of the ladder is here, the wall is here, and we're supposed to find x. So what do we know so far? We know the hypotenuse is 3.2, which is the length of the ladder. We also know the reference angle, which is 38 degrees, and we're looking for the opposite, right? So our triangle looks something like this: 38 degrees, the right angle, and 3.2 meters being the hypotenuse. All right, so we've got opposite, hypotenuse, and the angle. So which one is that? Always remember, okay, so we've got opposite and hypotenuse, which is this one. So we would use sine, okay? Sine 38 degrees is equal to opposite over hypotenuse, x over 3.2. So x would be 3.2 sine 38. Put this in the calculator and see what you guys can get. Okay, so the answer will be, let me put it in the calculator, will be 1.97 meters. Okay, because what they ask you is to correct to 3 significant figures. So you give it in 3 significant figures, which is 1.97 meters. Okay, let's go to the next one. A chairlift is inclined so that it rises 13 meters for every horizontal distance of 15 meters. Find the angle that the chairlift makes with the horizontal. So if we look here, so this is the reference angle, and this is the right angle. So the side which has the reference angle and the right angle will be the adjacent, so we'll label it A. And we've got the side directly opposite to the reference angle, which is opposite. We'll label that O. Let's have a look and see which one has O and A. Not sine, not cos, so it's tan. So TOA. So we have tan theta is equal to opposite over hypotenuse, opposite being 13, hypotenuse being 15. Okay, now we need to make theta the subject. So what do? Take theta, make it the subject, and when we're taking tan over to the other side, what happens to the tan? Remember, it becomes tan inverse. All right, so we have tan inverse 13 on 15. And what now? Put this in the calculator and see what you get for the answer. The angle should be 40.91, and just round it up to the nearest degree, which will be 41 degrees. Okay, let's go on to the next one. A kite is flying at a height of 23 meters on a string 29 meters long. Okay, so the length of the string is 29 meters long, and the height of the kite from the ground is 23 meters. Find the angle of elevation. So angle of elevation will be looking up, and the horizontal will be the ground, so we're looking for this angle over here. What information do we have now? We've got the hypotenuse, which is 29, and we've also got the opposite, which is 23. Which one has opposite and hypotenuse? That's sine, so we use sine. Sine theta is equal to opposite over hypotenuse, 23 on 29. So what's theta? Theta is equal to sine inverse 23 on 29. Because remember, when we're making sine theta the subject, sine becomes inverse because we're taking sine over to the other side. Put this in the calculator and see what you guys can get. I got 52.48. We rounded down to the nearest degree, so 52 degrees. All right, let's move on to the next one. The diagonal of a rectangle is 7.2 centimeters long and makes an angle of 32 with each of the longer sides. So Let's have a look over here. We've got a triangle like this, and this is L, this is 32, and this is 7.2 centimeters. What are they asking us? To find the length of the rectangle, correct to 2 decimal places. What information do we have now? Let's get rid of this part. Oops. Draw a proper one. Yeah, that's better. We've got the reference angle. We're looking for length, which is adjacent because it has the reference angle and the right angle on the same side. And we've got the hypotenuse, which is 7.2. Which one has adjacent and hypotenuse? Cos, right? So we use cos 32 is equal to adjacent over hypotenuse. Adjacent being L over hypotenuse being 7.2. L is equal to 7.2 cos 32. Okay, that would give us, let's put that in the calculator, 6.11 centimeters. Okay, and they're asking us to correct to 2 decimal places. That's why we gave it as 6.11. Alrighty, let's have a look at the next question. A car drives 15 kilometers due north. So 15 kilometers due north. Let's label that 15. That's north. And then 17 kilometers due west. Okay, that's 17 kilometers and that's west. Okay, and they're asking us what the bearing is from its starting point. Alright, let's have a look. So this is our starting point, this little dot over here. Let's call that O. Actually, that's a bit confusing. Instead of O, we can call that, just put a dot. Okay, that's our starting point. We need to find out what this angle is. So what information do we already have? We know that when going north and turning west, it makes a 90-degree angle, so we can put a right angle over there. And we've got the reference angle here, but we don't know what it is. So knowing that, we already have adjacent, because right angle and the reference angle are on the same side. We call that A. And we've got opposite, which is directly opposite to the reference angle, so we call that O. What are we looking for now? We're looking for the angle. Which one has opposite and adjacent, which that ratio would be tan. So we have tan theta is equal to opposite over adjacent, opposite being 17, adjacent being 15. Okay. Now, to find theta, what we need to do is we need to make theta the subject, so tan inverse opposite over adjacent, which is 17 on 15. This would give us 48.58. Okay. 48.58 degrees. Let's call that 48.58. Now we need to find out what the bearing is. Okay. To find out the bearing, we're starting from here and going all the way over here. Okay. So if we're going all the way over here, we need to find out what this angle is, and we know that this angle is 48.58. Since x plus 48.58 makes a full circle, we know that we need to find out what x is. We need to take away 48.58 from 360. Okay, taking away 48.58 from 360, let's do that. Put that in the calculator. 360 minus 48.58, that gives us 311.42. 311.42 degrees. Right, but since we need to give it as a bearing, we can only give it in 3 figures, which will be 311 degrees true. And that's our answer. Okay, let's move on to the next one. The diagonal of a square is 9.6. Find the length of the square's side, corrected 3 significant figures. Okay, so we know that a diagonal of a square is 9.6 centimeters, and this will be the right angle. This will be the same size. Okay, because that's the diagonal of the square. and the square has the same side lengths. Okay, we'll call it x. One way we can do this is use Pythagoras theorem. All right, we know that 9.6 is the c side, which is the hypotenuse, so we know that a squared is equal to b squared. Sorry, c squared is equal to a squared plus b squared. C squared over here will be 9.6 squared, and a squared plus b squared, x squared plus x squared gives us 2x squared. Okay, I'll show you guys how to get that. 2x squared is equal to 9.6 squared, which is what? Let's do 9.6 to the power of 2, which is 92.16, right? 92.16. Now, look for x. Divide both sides by 2 and square root it. We should give you 6.79, right? To 3 significant figures. And always remember the units, which is centimeters here. Alrighty, next one. The base of an isosceles triangle is 12.8 centimeters, and the height is 15 centimeters. Let's do that. The height is 15. Centimeters. The base is 12.8. What are they asking? Find the size of the base angle. So this one would be 90 degrees, and they're asking us for this angle, or this angle, because it'll be the same. It's isosceles, remember? All right. What we have over here is a triangle like this, and this is 15, and this will be half of 12.8, which is 6.4. To find out what the angle is, we need to figure out what sides we've been given. We've been given adjacent and opposite. Okay, which one has opposite and adjacent? That would be tan. So what we need to do is tan inverse opposite over adjacent, 15 on 6.4, and find out what that gives us. Let's put that in the calculator. That gives us 66.89 degrees, and we need to round it up to the nearest degree, which would be 67 degrees. And that's it. Alrighty, let's move on to the next one. Two cyclists leave the same starting point. Okay, the starting point is here. And one travels in a direction with a bearing of 135. That's this one. And the other one travels in the direction of with a bearing of 225, so that's this one. Oops, it's a bit wonky. Alright, now until he is 32 kilometers due west of the first cyclist, so that's the 32 kilometers. Alright, now what are they asking us? They're asking us find the distance of each cyclist from their starting point. So we know that they're both 32 kilometers apart. Okay, this one's 32 kilometers apart and this one's 32 kilometers apart. So what we need to find out is the distance of this one. And from the looks of it, it's an isosceles triangle, because have a look at it, the angle over here. It would be 225 minus 135, which gives us 90 degrees. All right, knowing that this is 90 degrees now, we need to find out one of these lengths. To do that, we need to draw the triangle again. It'll be 90 degrees. It's not to scale, but and split it in half. Now, this side will be 16 kilometers because we split it in half. And this angle would be 45 degrees. Alrighty, now this one becomes a right angle, and this one has 45 degrees. This one has 45 degrees as well. Alright, so this means this one and this one are the same. Alright, knowing that they're the same now, what we need to do is use Pythagoras theorem. Alright, so since we know that this side is 16, this side would also be 16. 16 squared plus 16 squared. What's 16 squared? That's 256 plus 256. And what does that give us? 512. Then we square root 512 to get the side of the hypotenuse. Oops. Alright, just find the side of length of the hypotenuse. So we square root to 512. Let's put that in the calculator. That gives us 22.6. Now, we can't leave it at that because they're asking us how many kilometers, right? The distance. So it will be 22.6 kilometers. And remember, the answer should be to 3 significant figures. All right, last question. Standing on top of a building that is 42 meters high, an observer sights 2 objects, P and Q, on opposite sides of a building. All right. The angles of depression from the observer to P and Q are 36 degrees and 23 degrees respectively, which is shown over here in the diagram. Okay. Find the distance between P and Q to the nearest centimeter. So that's probably going to be to 2 decimal places. Alrighty. Now, let's draw up the 2 triangles. We've got one triangle like this, which is P, and the building here, 42 meters. And see, the angle of depression is 36 degrees, so the angle of elevation from P to the building, P to the observer, would be also 36 degrees. Okay, that's an important fact to remember. Okay, so if the angle of depression from an observer to an object is 36 degrees, the angle of elevation from the object to the observer is going to be the same, 36 degrees. Alrighty, now that you know that, we can also tell that the building and the ground would have a 90-degree angle. Now, what we need to do is find the distance over here. So what do we know so far? We know the reference angle, we know the opposite side, which is 42 meters, and we are looking for the adjacent, which has the right angle and the reference angle. So what would that give us? Which one has opposite and adjacent? Tan, right? So we use tan. 36 is equal to x, no, not x, 42 on x. So x would equal to what? Oops. Zoom out a little bit. X would equal to 42 on tan 36. Put this in the calculator and see what you guys get. I got 57.80 meters. Okay. Now, let's do the same thing for the other triangle, which is this one. Okay. We start with 42 meters, and the angle of elevation from Q to Q to the observer will be 23 degrees, because if the angle of depression is 23 degrees, the angle of elevation is going to be the same. Now, what do we have? We've got adjacent and we've got opposite. We're looking for adjacent, right? So we're doing the same formula, tan 23, tan 23 degrees is equal to opposite over adjacent, opposite being 42, adjacent being x. Okay, let's not call it x because the last one was x, let's call it y. Alright, so now y is equal to y is equal to 42 on tan 23. 42 on tan 23. Now, just put this in the calculator and see what you guys get. Put it in mine. I got 98.94. Let's put that in. 98.94. But remember, when you're using numbers and rounding them up, you can't use the numbers that you rounded up for the final answer. Because remember, you're adding up this distance and this distance, okay? So when you're adding these distances up, you can't use the rounded up values. So you need to use the exact values, add them up together, and then round it up at the end, okay? So let's do that in our calculators. So 98.94 and 57.80. Let's find the exact values, add them up. I got 156.75 meters. Okay, and that's my answer. All right, if I had added up the values that I rounded up, which is 98.94 and 57.80, I would get 156.74 meters, which will be incorrect. It has to be 156.75 meters. All right, so remember that, guys. Always when you're doing your rounding up, always round up the final answer, not the answers that you get along the steps. All right, and that's it for trigonometry, and we'll do geometry next week. All right.